Oh, there you go. Hello, guys. So today I'm going to go ahead and be talking about how to just find the scale factor between solids. Okay, it's going to be very fast, very easy, very straightforward. So a few things that you will need to in order to follow me along will be uh, one, I will be using a calculator. Okay, it doesn't have to be anything fancy. I'm going to be using this Desmos calculator. It's a scientific one. If you just literally type that online, it takes you here directly, and it's awesome. It's amazing. Makes it pretty simple. Other than that, honestly, that's all you need. Okay, so so here's the problem. So I'm going to be looking at. I'm going to be talking about one, two, three, four problems right now, and hopefully that'll be enough to get the idea across. Well, first, in general, and as you can tell on these pictures, similar solids, just like similar shapes, they overall look the same. The one thing that they have different is that obviously they're a different size. They either get bigger, as you can see on number one and number two, or they get smaller. Okay, and again, that's pretty much it. Now, if you recall when we were doing similar figures, 2D shapes, in order to determine if something was similar, we had to look at the sides, and that's what we're going to be doing here. Okay, so we're going to be doing a corresponding sides. We're going to be matching them, and if both sides or whatever numbers they give us, if they have the same proportion, then we can say that they are similar. Let's look at number one. So on number one, they only give you two numbers on each figure, a 9 and a 4 and an 18 and an 8. And already guys, just by looking at it, you'd be like, oh, I know the answer. They're similar because this one's twice as big. And honestly, that's all you have to do. But if you want to get a little bit more, into a little routine or like, what am I going to do for all my problems? This is what you would do. You're going to pick a number, no matter which one. Right now, I'm just going to go with that 9. Now, that 9 right here is this little dotted line. And in this picture, that 9 looks like the 18. So there you go, 9 over 18. I'm going to go ahead and put that in my calculator. You don't have to leave it in fraction form or decimal form. Doesn't matter. Doesn't matter how you see it. When we're just comparing to see if they're similar, it doesn't really matter. Later on, then when we're solving for things, it comes a little bit more handy to leave it in fraction. But anyways, 9 over 18, that's 0.5, also known as 1/2. All right, just keep that in mind. So I'm just going to put it like that, also known as 0.5. Let's look at the other number they gave us. Well, they also gave us a 4, when that 4 goes with the 8. Now, you guys will know that 4 over 8 can be simplified to 1/2, which in the end is the same thing. And so in this scenario, because the ratios are the same, we can say that the solids are similar. Just like that. Let's look at number 2. Let's see if this one is similar as well. I'm just going to go ahead and copy this little box and put it right here. Oops, looks like I did already. It's overlapped it. Eventually I'm going to need another one over here. So since I already did it, let's move it down here as well. All right. Let me go ahead and zoom in here a bit. I'm going to erase this. I'm going to be doing a new one, and I'm going to be erasing this since I'm going to be doing a new one. All right. So on this one has 3 sides. All you're going to have to do is just look at each one. All right. So first, let's look at that 6. That 6, this part right here, looks going up and down. So that 6 corresponds with, the 10 on the other side. So 6 over 10, right? So now you have to simplify this. Hopefully you guys could simplify in your head here, right? We could divide everything by 2's and end up with 3 over 5. If not, honestly, it's not the end of the world. Although it is a skill that I would really love for you guys to have, it's not something that's going to, completely ruin it for you. We have calculators and we can use them. For example, this 6 over 5, I was just to put it right here. I get, was 6 over 5, 6 over 5, oh, 6 over 10, my bad. So it was 6 over 10. And I'm getting that 0.6 that you saw, but look at this right here. Convert to fraction right next to it, 3 over 5. So again, it's not a big deal. Not a big deal. However you want it, calculators can give that to us. We have a 3 in the bottom. All right, so that 3 goes with that 5. Okay, this one can't be simplified anymore, so we already know it's just 3 over 5, and in decimal it's still going to be that 0.6. Let's look at this. They have another number. So far so good. We're having the same ratio, so it looks like it's going to be similar. There's a 2 here, and then there's a 4 on the other side. Again, keep note that they're corresponding, and that's why I'm matching them together. Now 2 over 4 simplified is 1/2. This one right here does not match with the rest. If there is at least one that does not match, the ratios aren't the same. And therefore, the solids are not similar. Just like that, just like that. So again, here, the numbers that I had, they were all had the same ratios. Here they didn't. Not similar, similar. One more over here. Same concept. Look at that 15. That 15 is the height of my pyramid right there, and that corresponds to the 6. I could simplify by dividing by 3's. 15 divided by 3 is a 5. 6 divided by 3 is a 2. So that's going to give me a nice 2.5. Let's look at this one over here. We have the 10 and we have a 4. Well, 10 over 4, again, I could divide by 2's again. 5 over 2. And we're going to end up with the same thing. So because the numbers that they provided us are the same, we can say that they are similar. Yes, they are similar. I got one more, and that's it. Again, that's how easy this stuff is. I just want you guys to have examples that you guys can look at and be able to do these no problem. So in this figure we have cylinders. Now you're going to see how that 8 is the radius. It is the radius of the big cylinder, and the radius of the smaller one is 2. So 8 over 2 is simply 4, right? I'm just going to put a 4 over 1, right, which again gives us 4. I like to see them in fractions. We have an 18, and that 18 goes with that 6. Okay, and 18 divided by 6 is 3. This is not the same thing. So because it's not the same thing, obviously they are not the same. The ratios are not similar. So, well, the ratios are not the same, therefore not similar. And again, pretty much it. Again, it goes to the whole thing. If they're the same, they're similar. If they're not the same, they're not. And that's it, guys, on how to determine if two solids are similar or not by looking at the scale factor. And that's it, the scale factor.